Let's talk about write blockers now. So what is a write blocker? So it's either a hardware device or software mechanism that intercepts and blocks all write commands before they actually reach the storage device. So this allows you to read information, but not send any information or change any information going to the particular drive or device. So the write blocker sits in between, typically in between your analysis workstation and the actual evidence device. And so you can read information there, but you end up blocking it. It needs to be generally at an OS level or at a hardware level just to ensure that nothing is changing anything. Because when you plug a drive into a Windows computer, for instance, it will automatically index the drive and may modify some of that information. On Linux, you can have a auto mount to where you plug a drive into a Linux computer and it will automatically mount a USB drive or some other device for that particular user and may change some information. Virtual memory and paging can also write to those connected drives, and antivirus, which should be running on every system out there, would automatically start or could automatically start scanning all the files in there and may end up changing things from timestamps to actually quarantining files if they are found to be malicious. So, hardware write blockers. It's a physical device, and typically these days it plugs in through the USB port on your system. There are some which will connect through a SATA port or an eSATA connection, and they have a number of other ports on them for drives to get connected to. So they intercept the SCSI or ATA or USB command packets, drop any write command before it reaches the drive controller. No software drivers involved. And so these are devices that can work across the operating system, across hardware, as long as it can be physically plugged into a computer and the computer can see that as a drive, then it will just work. There are a number of vendors out there, Tableau or OpenText, ICS, and several others produce widely used forensic write blockers. The T3U and T35E are older write blockers, and there are newer ones, and the prices for that range anywhere from, if you get an old write blocker, you can find them on eBay or elsewhere for like $200 a piece. The newer ones, they can run several $1,000s depending upon how they actually function and what sort of features and functionality there are. There are even write blockers out there which are kind of a mini computer that you plug your source drive or your evidence drive in and your destination drive, and then it has its own interface. You just press a button there and it automatically just copies everything and generates the hashes and everything without having to use another computer there. Those are typically a bit more expensive, but they are a easy button press and accepted by courts and everybody as doing things in a forensically sound manner. Modern forensic write blockers support pretty much any connection. So SATA, SAS, IDE, USB, FireWire, PCI, NVMe, SD card. Really, it doesn't matter, and the most modern write blockers will support any of those. And again, the advantage is it's OS independent, so it doesn't matter what operating system you're doing this on or what other hardware you're doing this on. It just sits there and blocks it regardless of that. And there's typically LED indication to indicate whether things are getting blocked or things are getting copied, things like that and things of that nature. And all major forensic standards bodies support write blockers and they accept all of those. Software write blockers are a little bit different. These are very much OS dependent, depending upon if you're running Linux or you're running Windows or even sometimes which variation of Linux. depends upon how you do it. So having a good, strong understanding of the operating system and what it actually does when you plug a device into it is important to ensuring that you have a write blocker in the software stack. So in Linux, you can create what's known as a UDEV rule, or I believe UDEV stands for Universal Device Rule. And these are rules which are triggered when a device is connected to the operating system. Think of a USB device or a camera or some other removable device. And so if you create a file under etc udev rules.d, you name it. In the past, it was, I believe it was, it ended in .rules. Different operating systems, different versions changed that extension from rules to something else, and I can't remember what it is. You'll just need to check and make sure that your operating system, whatever version it uses, it's consistent with that. But you basically write out to that file the subsystem block attributes removable 1, and then the attribute read only to be a 1. And that will, and if it's done correctly, that will mean that when a removable device is plugged into that system, it will be automatically flagged at the kernel level as read only. Afterwards, then you reload the rules, and then you can trigger it, and then you'll need to make sure that it actually is read-only. So you would test that with another device, not the evidence, plug it in there, and then you can view the block device and view whatever devices are on there to see, is it read-only? And so you can use the blockdev command. You can also use blockdev to set read-only on a specific device, but generally that would have to happen before the operating system starts manipulating it. Windows registry, there is under HKey local machine, system, current control set, control, storage device policies. You can create a write protect key with a 1 there, which will then add write protection for storage devices. You do have to restart the system after you do that. But once you do that, plugging in a storage device, whether it's USB or SD card or whatever, Windows kernel should say it is write protected and not allow any write commands to go to that. The problem with all these is you can have what's known as a race condition, to where as a operating system is booting up, there may be some service or some process which tries writing to that device before it's fully booted up and before it gets to these particular policies. You also have to document everything. So you want to ensure why a software write blocker was used and why a hardware blocker was not used. Maybe the device broke, or maybe it was in use elsewhere and there's a time crunch. There's many reasons why you might use a software write blocker, but generally, at least in a legal forensics realm, you want to ensure that you use a hardware write blocker when at all possible, just because they are much more robust and less questionable as to why you're doing things the way that you're doing it. Verifying it, same thing, is once you have a device and it's mounted and it has a write blocker, either hardware or software, you shouldn't be able to write anything to it. So like step number 2, well, step number 1 is you get the hash of the source device before you connect the write blocker. Then you try to write something, and that's step number 2. And so that echo is just going to send test to the output file. And in this case, it's going to literally try to write test over the beginning of that particular drive. Should be read-only. This is very, very dangerous if you are not 100% certain that you have a write blocker enabled. If you are doing this to test whether or not write blocking is enabled, then you need to make sure that you take other steps to ensure that write blocking is enabled. Then you want to hash it afterwards. You can check the hashes, verify all that, and then you can document and save all of that. So this is really more of you know that the write blocker is enabled, you know that's correct, and you want to document and verify for any legal purposes or court purposes that there is not any possibility of any change to that particular device. So kind of looking at the comparisons between them, hardware is fully independent, software is operating system dependent. Depending upon the operating system, depends upon what you need to do for that. The bypass risk, hardware happens at the physical layer, so the operating system can't bypass it in any way, shape, or form. Versus software, that's up to the operating system. There could be a bug, it could be implemented wrong, so on and so forth. And so you need to take steps to ensure that it is done correctly and is repeatably reliable. Again, hardware is usually the first choice. Software, assuming or if it is done correctly, could be an accepted fallback, but I would always lean towards a hardware solution if at all possible. Evidence drive interfaces, that's one of those where a hardware device, especially a hardware device with lots of different connections, would be more usable than some software block, because a software block, your actual system has to be able to physically connect that drive. And if you have an older drive, an IDE drive, for example, then you have to get a separate IDE enclosure to mount it on a modern computer. If you don't have a SD card slot, then you would have to get a reader for your SD cards. Whereas a lot of hardware blockers may already have that built into it. Cost, that's the big difference. Hardware blockers are not cheap. I put down $300 to $600 plus. You're looking at, for really big and robust systems for hardware blocking, you're looking at maybe $2,000-$3,000 and maybe up from there. Really depends upon what the purposes are. For general use, you can get a $300 to $500 USB device that will be a hardware blocker and would satisfy probably 90% of what you need to do. But if you are working in the law enforcement realm or working with a court case or anything, then you may need devices which are more expensive than that and have more functionality and logging and everything else. Software is free. I mean, you can go into the operating system, you can configure all of it, so it is free. There are trade-offs to all that. Again, hardware locker, write locker, you have to carry around with you. So whatever kit bag you have, that would be an additional space for it. Smaller ones, again, the more commonly used ones, aren't much bigger than a cell phone and can just slip into a bag. Bigger ones typically look like a separate briefcase that you can carry around there. Software, don't need anything else. Documentation really kind of depends upon what you're doing, but just document all the aspects and components for whatever write blocker it is, and you'll be fine. Setup time, again, software, once you set it up, you need to verify it, but then it should happen automatically at every boot. Whereas hardware, you just literally plug it in and go. And there's nothing else that really needs to happen with that. So again, some key takeaways. Make sure you have a write blocker. For this particular class, we're going to set up a write blocker on Linux, but most of the stuff I'm not going to say, okay, go out and buy a write blocker or copy this image using a write blocker and things of that nature, just because for the educational purposes, it doesn't really matter as much, because again, in the real world, typically you'll use a hardware write blocker, and it's a simple matter of just plugging it in there and then going from there. It's a little bit more important to go through the analysis process and actually duplicating the drive and verifying the MD5 sums and or whatever other hashing than it is to go out and buy a write blocker just for learning purposes. And again, it should be hardware. Software is a fallback, but should never be your first choice. and you want to verify that it works, and you want to take hashes of everything. And different drive interfaces require compatible write blockers. So obviously, if you're doing something, you want to make sure that the drive that you're hooking up will actually work on your particular write blocker.